a l'occasion d'accueillir, le plaisir d'accueillir M. Butler, qui est un professeur de microbiologie en Australie, à Adélaïde. Donc on a la chance de rencontrer ce monsieur qui a travaillé toute sa vie, pendant 35 ans, il m'a dit tout à l'heure, sur le microbiote intestinal, à la fois chez l'adulte et chez les enfants. Donc il travaille vraiment de façon collaborative avec les gastro-entérologues, il s'intéresse à toute cette flore digestive, et même en physiologie, quel impact ça peut avoir. Donc il me fait l'honneur d'être là aujourd'hui. Je lui laisse la place, après, parce qu'il m'a parlé des méthanogènes, M. Butler, ce matin. Si d'autres personnes sont intéressées, parce que c'est clair que le microbiote intestinal passionne beaucoup de monde en ce moment, donc Émilie, si tu veux venir taper la discute, ça peut être bien, n'hésitez pas à venir le voir. Il est vraiment demandeur de collaboration, et puis éventuellement, je pense que si jamais il peut accueillir des personnes, il le fera sûrement. Donc n'hésitez pas à venir le solliciter à la fin. Voilà, merci beaucoup d'intervenir.
Unfortunately, I have to speak in English because I can't speak English. I'm sorry. Thank you, Stefan, and thanks to Professor Raut and Drancourt for inviting me. I'm going to talk to you today about something you probably have little contact with, but it's something that I've been doing for many years, looking at different kinds of non-invasive biomarkers in breath and in other areas, including feces, but I'm only going to talk about breath today. And I've recently moved from this hospital, which is the Women's and Children's Hospital, but I'm still there for a small amount of time every week to maintain the clinical connection. So I've become emeritus there, and I now have a chair at the University of South Australia, which is just over here. You can't see it. And the Central Business District is up there, and the cricket ground is over there. That's just a closer picture of where I used to work, which is here. So the women's part of the hospital is here, and the children's part is here. Just a little bit about Adelaide. That's the Central Business District, if you were to look to the top of that last picture. And that's a church, and that's the CBD, and there are our hills. We also grow vines and produce wine. And this is just one of the 5 or 6 regions around Adelaide. And this is the closest region probably, which is McLaren Vale. I used to say this looks like France, but it probably doesn't. I just tell other people that. Okay. Where I used to work, we looked at all of these sorts of diseases, inflammatory bowel diseases. I worked in gastroenterology in the gut, so I'm interested in the intestinal microbiome and how it interacts with the gut and how our gut responds. We also did motility studies in those sorts of settings. At the same time, I set up what we'll find out in a minute is the Stable Isotope Biomarker Engineering Centre, and that's to develop non-invasive tests of gut function and various formulations and deliveries to all parts of the gut to treat the gut, and that's both for infectious diseases such as Helicobacter pylori, probably inflammatory bowel disease, although we don't really know what particular organisms or organism are responsible. And we do preclinical and clinical trials. It's largely a clinical translation scenario here, and here it's to devise new ways of understanding or interrogating the gut and the gut contents. And because I've just come from the International Agency of Research in Cancer, where now that I've moved from a paediatric setting to a university setting, I'm able to go into adult medicine as well as paediatric medicine. And cancer risk was one of my previous 15, 20 years ago. I worked on cancer risk, and I'm coming back to that by devising new tests of gut function. I'm going to show you some that we've done, and then put up some prospective studies, or ideas really. So that's what SIDEC stands for, Stable Isotope Biomarker Engineering Centre. And it's a place where we can formulate probes that are stable isotopes so we can use them in children. They're not radioactive. And we look at breath tests and other metabolites and we can also devise ways of looking at volatiles as well. So I've set up a system now where we've got 3 isotope ratio mass spectrometers and a SIFT, or a selected ion flow tube mass spectrometer, and various other smaller machines to look at volatiles in the breath. We focused on developing non-invasive biomarkers and diagnostics, and also producing therapies. And today I'll talk to you about the way we went about looking at a potential therapy for Helicobacter pylori eradication, given that the current therapies are becoming less and less effective. And also a new breath test that can tell us what degree of damage there is in the small bowel. And also I'm proposing that we can use this same paradigm to look at early markers of gut cancer, particularly esophageal and gastric. There are no early markers really that are effective, so 80% of the people that, when they're diagnosed, because they're diagnosed late, die. So we need to be really looking at doing those sorts of things to get translational activity, as well as keep doing discovery research and looking at all the omics that we are subject to now. I've got market area there because many of these things can be commercialised and may go into that. And in the gut, 15 to 20% of the population, I imagine it's the same in France, have gut disorders of one kind or another. Mostly morbidity, not mortality is the response. So the opportunities, apart from the ones I'm going to show you, that we've already realised to some extent, is to develop some early cancer biomarkers, but that isn't the end of it. And in the final analysis, the aim is to get better clinical management. So to use our science to become more proximal in our approach, which from talking to Stefan here, you're doing that with your point of care activity. This also is point of care, but it's a different construct, a different paradigm, a different strategy. It's more functional and probably not quite so cost effective. So the capabilities of this new facility are to provide new non-invasive technologies, and that isn't only confined to what I'm going to talk to you about today, but that's all I have time for. To reduce the cost and risk of new GI fundamentally, but not just GI, not just gastrointestinal therapeutics. This is probably the most important thing we should be doing, I think, improving translation to the clinic. Our science is so powerful now in many different arenas that to some extent we've failed to translate in an effective way. Demonstrate efficacy of different products. We just use this technology in clinical trials to demonstrate, particularly in remote regions, these tests can be sent anywhere and they can come back and we can analyse them after even a year for breath tests at least, without any special storage capability. Obviously we want to expand therapeutic indications, I won't talk about product extension, and develop, in this case, I'm going to give this paradigm as the last part of my talk, to develop early cancer biomarkers. So I'll talk first about Helicobacter pylori, the non-invasive test that was a breath test that was developed for that, and we were the first in Australia to bring that into play for a stable isotope breath test. And then I'll talk about the breath test for damage to the small bowel and try and convince you that this is a paradigm for developing some early cancer biomarkers. We also worked on probiotics and prebiotics and factors that will change the intestinal microbiome, which has yet to be really fully realised. I think the sorts of techniques that you're using here are the ones that we need to start to develop, and we're doing some RT-PCR work in fecal microbiome and also in luminal contents we're collecting with a newly engineered device, which I'm not going to talk about. So I won't really talk about that, but I will talk about, we developed a hyperimmune bovine colostrum some years ago for rotavirus infection, and that was 15 years ago or so, and that was prior to the active vaccines that are now on the market. there still is a place for this sort of thing. And we've been doing it for Helicobacter pylori, largely because Helicobacter pylori is developing worldwide a very strong bacterial, strong resistance to antibiotics. So, and it's always had to have at least 3 different agents, a couple of antibiotics and perhaps a proton pump inhibitor, a changer of the gut or the gastric milieu to actually have a positive effect. So where we used to get 95% kill, we now get 60, 50, 40, and we get also very bad compliance often because they're not very nice drugs to take. So we're using this system, and we showed in vitro, and we patented this. It showed in vitro that it was highly bactericidal, this HBC plus some other things, which I'll show you in a minute, highly bactericidal against H. pylori, which nearly everything is anyway, because if you can't grow it easily in culture, which is what happened originally until we've had some luck, and Barry Marshall and Warren found out that by leaving it over 3 or 4 days, they were able to grow H. pylori. Then it's easily killed outside of its adapted environment. And in vivo, we've shown that it can decrease colonisation, but can also kill. So, and I'll show you that data in a minute. Whether this gets to, the main aim of this was to go to the developing world where they can't really afford the antibiotics anyway. And if you start to swamp whole regions with the current triple therapies, you won't, they'll rapidly lose any efficacy they've got. So these are just the sorts of players you need to put in to get a preventative and a therapeutic for anything, but certainly for H. pylori. That's just my unit at the Women's and Children's Gastroenterology. We worked with the other university, one of the other universities to do it, and various companies in Holland and Australia, and the Australian Research Council and the Anti-Cancer Foundations to really affect, to get a therapeutic to a point where it may well be, get through FDA, etc. and EU. We focused on colostrum because colostrum does, because of our interest in how the gut responds, colostrum has a whole range of things we don't really know too much about, but it certainly dampens inflammation anyway. So we were trying to hit a bug that adapts so well in the stomach with a number of different ways to stop its activity. And in fact, we're moving even further with that now in a very in a what I would call discovery phase by looking at H. pylori and its effect on phagosome, endosome, lysosome maturation, which may well be a very important component of its way of evading the immune system, because we get a big immune response with H. pylori. This is just the research strategy in general. I won't go through that in any depth, but we've looked at it with a whole range of other components and done a lot of animal studies with the mouse model and a few preclinical. We haven't yet done human clinical, and that you often need a commercial partner to do that side of it. So the use of Fibroimmune bovine colostrum to treat H. pylori. Drum and Roland were a paediatric gastroenterologist, and his wife, a paediatric epidemiologist, stated this some years ago, saying that it's acquired in early childhood, and I think that's well accepted now. H. pylori is usually acquired before you're 5 years of age. It's different in different parts of the world, and the recurrence rate's different in different parts of the world. And it stays with you for the rest of your life. We were focusing on developing countries close to our region, Indonesia, Southeast Asian countries, and even China back then, and India. It's turned a little bit now. They're becoming much more developed in, at least in high populations, about 300 million in each of those countries are now what we would call emerging middle classes. They'll probably start to get the sorts of diseases we get. And I think France would fall into the same category as Australia and the US